start this. So the first thing I wanted to do was just show you guys on Moodle what's going on, because at the end of this week, right, you'll have done quite a bit of material, and so there's a Moodle quiz that's due as an assignment 1 Tuesday night at midnight. Pardon? No. And so here, I've shown you this before, right? But here's the link to the YouTube videos, which have all the lectures, right? So I post those after class, or there's the Zoom information. I also posted this Learning Center practice problems and solutions. It's just a link to that page, okay? And so if you click it, you get here, and there's all kinds of different worksheets that you can do with solutions on the side, right? So if you feel like maybe you need a little bit more bed mass practice for FOIL that we're about to do today, it's going to be review, right? But if you need more practice with that, there's worksheets for that here with solutions. We talked about fractions last day, right? And so if you want to work on fractions, right, kind of getting up to speed. And then, so there's quite a few worksheets here that if there's something in particular that you feel you might need to work on, there's lots of worksheets and solutions there. Okay? So that's put up by the Learning Center. But if you have any questions about it, of course, you can send them my way. Okay? So you've probably noticed that at the end of every day, I post the notes that I wrote, right? Whoops. Wait. So here, so now we'll finish 1.5 today. We actually, looking through my notes, we easily could have done 1.6. I don't know why I didn't just squeeze it into today, so we don't have that much to do today, but nice to spread it out, I guess. Right, but assignment 1 is due next Tuesday at midnight. I will not reopen the assignments, so make sure you get them in, okay? But the assignment will look like this, so I was just kind of fooling around, don't worry. But let's say you put in your answer here, you find your answer, you're allowed to check it. You can check it as many times as you want. It'll just tell you if it's right or wrong. Now, 12 divided by 12, let's see here. I forgot my business calculator today, so we'll make it work, but 1.03173, and then 7620 divided by that guy. For example, 7385. Does it say how many decimal places? Let's try 2 decimal places. Love that green. Okay. So you can make sure that you have the right answer before you submit it. Right. Yours will be different, but same idea. Okay. All your numbers will be different, but the same question. Right. So you can go through and check it. It does take the average, right? The average of all your submissions. So let's say you submit your first attempt, so you have unlimited attempts, but let's say you submit your first attempt and you get 4 out of 10. Then you try it again, right? Get 10 out of 10. Takes the average of those, right? So 40% and 100% takes the average. But then what if you tried it a third time, got 100%? Now you've got 200% to outweigh your 40%, right? And that's not so bad. Question, Arm, or? Looked like a question. No. I'm ready. Yes? Okay, so that's how the quizzes will work. They'll close and be done at midnight on Tuesday. So I want to make sure that you do those. Okay, and I think I've posted all of them already. How many assignments are there? There's 1 week with no assignment. There's 10 assignments total. Any questions about that? No? Tickety boo. Oh, what math? No, business math. Oh, I feel like I made one. Yeah. Okay, so just brief review. We just met on Tuesday, so it's not that long ago, right? But we talked about bed mass, right? Brackets, exponents, division, basically what's legal in math and what we can't do, right? And then, so for review, we talked about bed mass. We also talked about fractions, right? The terminology that I need you to remember is that a fraction is a numerator over a denominator. We also talked about adding and subtracting fractions, which is a little bit harder, right, than multiplying or dividing fractions. So we talked about all those, and like I said, showed you those worksheets. There's more problems for you to work on if you run out of questions from the textbook, but there's quite a few in here too. Okay. Any questions from last day? No? Let's do it. So section 1.4 is on expanding and factoring. And just like last day, this is all a review, right? This is all things, or these are all things that you know, right? And so, but I just want to get everyone on the same page. Okay. Expanding, let's start there. I always like expanding better than factoring. But expanding is when you have something like A times B plus C. Right. To expand this, we get rid of the brackets essentially, right? And we do something like A times B plus A times C. AB plus AC. Okay. And now we don't have any brackets anymore. Okay. One really common mistake that I see is you only multiply the A and the B and then you forget about the C. Right? So be really careful when there's addition or subtraction in here. You have to tack it onto both. Okay. So just as a quick little example, if we have some numbers, 4 times A plus 3, if we're expanding this, right, we have to multiply the 4 in. So 4A plus 4 times 3 is 4A plus 12. Right. So far, so good. Factoring is essentially expanding in reverse, right? Now you've got these common 4s, for example, in the example we just did. Now we can pull those out in front and put things in brackets, right? Because we've got that common multiple. So is expanding in reverse. So for example, 4A plus 12, we just did it, but also we can look at this and say, well, there's no A in 12, right? And so we can't pull out an A, but we can see if maybe a 4 or a multiple of 4, like 2, that's our only option, right, can be pulled out of 12. Luckily, 4 can be pulled out, and so that's even better, right? But we can rewrite this as 4A plus 4 times 3. You don't have to show that step. If you went straight to 4 times a plus 3, that's fine by me. So what we're doing here is we pull out the highest common multiple. Factoring is nice because you can check your work by expanding it again to make sure that you're still at the right thing, right? What if I asked you to factor something like p plus PRT? Not too bad, right? There's definitely no R in the first term. There's no T in the first term. The only thing that we have is a P, and luckily we have a common P on both terms. And so we can pull out that common P, and this P is just P times 1, right? Or 1P, right? And so we can't forget about that 1 here, because if we just said P times RT, when we multiply back in, we only get this term and we've lost that term, right? So that's another thing that you want to keep an eye out for. So you have to keep that 1 plus R times T. Okay. Expand to check. P times 1 plus RT. P times 1 is P plus PRT. Phew. Whew. Oh. What if I asked you to factor factor 3b plus ab plus 1 plus t times b? So you start and you just have a look. I think at a glance, we all see that there's that common b, right? But we have to be careful so that inside our brackets, we have what we need. So it'll stay the same, right? And so we see b is the only common multiple. So we get 3b, just rewriting the equation down here, or expression, sorry, plus 1 tb. So 3b plus ab plus 1 plus t times b can be rewritten as b times 3 plus a plus 1 plus t. If the goal was to simplify this, right, then we would kind of clean up in there because we can add 3 and 1, right? And so if we want to simplify, we find that b times 3 plus a plus 1 plus t in brackets is going to be b times 3 plus a plus 1 plus t, right? Because those brackets aren't actually doing anything. And if you wanted to get rid of them already, that's fine. B times, oh, sorry, 4. Because 3 plus 1 makes 4, and then plus a plus t. So that's still factored. Okay. What if we wanted to, so we get to this point and now we want to expand to check it, right? So expand to check our answer. So b times 4 plus a plus t, we want to know if that's the same. So I'll put a question mark over our equal sign. Does that equal 3b plus ab plus 1 plus tb? Doesn't look good, does it? It does. We know it does because we followed all the rules and things, right? And so this is just showing us that we need to be a little bit flexible when we're looking at these things and just kind of do a little bit of work, because with some manipulations, we can get these to be the same, right? What if we went the other way, right? And we simplified that side, right? And so we said, okay, well, 3b plus ab plus, and now we've got b multiplying 1 plus t, so we got to bring the b inside, right, if we're expanding it. So we've got b plus b times t. To simplify, right, we're going to collect like terms. And so we've got 3b. AB we can't collect because we don't know what A is. Right? B we can collect with 3b because they're just b's. Right? And then b times t we can't collect because we don't know what t is. Right? Unless we had more bt terms or AB terms. But we can do 4b plus AB plus BT. Now, whichever way we want to do it, if we want to expand the left-hand side, right, or if we want to pull out a B here, you'll see that they're the same. How about I'll expand the left-hand side since we're checking our answer. And so we'll do B times 4, even though for me, I always want to write the coefficient on the left-hand side. And you know what? I'm going to, because I want to. 4b. I always want the number on the left and then the variable on the right. It doesn't matter. The order doesn't matter because we're multiplying. Right? 4 times 2 is the same as 2 times 4. Right? Plus AB plus TB I guess if we wanted to copy it exactly, we would rewrite that last term as BT 4B plus AB plus BT. They're the same. So just kind of getting confident with manipulating equations and things like that, right? Moving things around and seeing, okay, well, I know I started here and I know I didn't do anything illegal, so I'll just keep working at it. Right. Okay. Any questions about that one? Cool. What if we have to expand something like this, where we have A plus B times C plus D? You guys probably just FOIL it out, right? Boom, 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 boom. No, not this way. Boom, 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 boom. All right. But there's actually 2 ways. They're very similar, right? And so the first thing that we can do, so we have 2 options. And it doesn't matter which way you use as long as you're using one of them. We have 2 options. The first one is essentially treating A plus B as one thing, right? And taking this times this plus this times this and breaking out those brackets. And then multiplying the C inside and then the D inside. And then you've expanded, right? So the first one looks like A plus B times C plus D is A plus B being left alone as one thing times C plus A plus B, oops, A plus B times D. And then, of course, bringing the C inside and then the D inside, we get AC plus BC plus AD plus BD. Right. Our second option is the one that I'm guessing most of you will use. Sometimes it's called FOIL. First, outside, inside, last. I don't know. It's been a long time since high school, but it looks like this. A plus B times C plus D, again, the same thing that we're dealing with. Okay. You're gonna do AC, that's your first thing that you're gonna do. The second thing you're going to do is A times D plus A times D. Third thing you're going to do is B times C. And let's see if I have a color here. How about orange? I ran out of room too. B times D. Oh. They do the same thing, right? Of course. A times C, B times C got bumped to here, AD is here, BD is here, right? But these exact same terms. So it doesn't matter, I don't care which way you do it. I think it's pretty fun to do this, boom, 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 right? And so I'll do that, but whichever way you want to do is fine. Okay? So let's do an example. First, I'm going to change this equal sign. So 23, expand and simplify. What if we have something like x plus y times 3x plus y? So I'm going to FOIL it, but however you do it is fine. Right, so let's just get cracking here. So we've got x times 3x, and instead of just combining them immediately to 3x squared, I'm going to show all my work, but usually I would probably just say x times 3x is 3x squared and move on, right? But for this example, I'm just going to show all the work. Okay? So we get x times 3x. Put it in brackets to show that that was one thing, plus x times y plus y times 3x plus y times y. And you definitely don't need those brackets. I'm just being careful. Okay. So now we've expanded. Now we have to simplify. And so we get 3x squared let's just write a little note here. In general, a to the power of m times a to the power of n is a to the power of m plus n, right? So what I mean here is x times x is just x squared, but that's because you have x to the power of 1 times x to the power of 1, and so you're doing x to the power of 1 plus 1, right? We'll talk more about exponents later, and so that's why I'm not diving into it, but for now, so x to the power of 1 times x to the power of 1 is x to the power of 1 plus 1, which is x to the power of 2. Okay. But we'll talk more about exponents later on. So we've got 3x squared plus xy plus 3xy. I rearranged it because I know I'm going to collect those terms, the xy and the 3xy, plus y squared, right? Y times y is y squared. I can collect these terms and say, well, that's 3x squared plus 3xy plus xy is 4xy plus y squared. We know we're done because there's nothing else I can do. I can't collect any more like terms, right? I've got an x squared term, I've got an xy term, and I've got a y squared term. Never the two shall meet. And so we're done, right? Simplifying can be tough because sometimes it's hard to know where to stop, right? And I'm not too picky, right? I don't even reduce my fractions. How lazy I am. It's all the same number. Okay. But any questions about that one? Oh. Let's do another one just in case. Example 24. Expand and simplify. What if we have something like this? X minus 2 times 2x squared minus 3x minus 4. Yowzas. I'm not going to show quite as much work here, right? But same idea. So x times 2x squared is going to be 2x to the power of 3, right? Just combining those x's immediately. And so we get, and we just apply the same principle, right? The FOIL doesn't just apply to a plus b times c plus d, right? We can have as many terms as we want, and we just keep kind of rainbowing it out. So we've got x times 2x squared is 2x to the power of 3 plus, oh, sorry. Well, I'll just keep it plus x times negative 3x plus x times negative 4. I wasn't sure, well, I guess I will. I'll just rewrite this. X times 2x squared. Show more work. You don't have to. I'm just trying to be consistent. Okay, so that's our first x brought in. Right now we have to do the negative 2, but I'm running out of room, so I'll just kind of move it to the bottom maybe. So we've got negative 2, so plus negative 2 times 2x squared. I'm just putting pluses in between and then keeping the negative on the number. But if you wanted to ditch the positive and just make it a minus instead, that's fine. Just make sure we end up at the same answer, and then how you got there. There's lots of different ways. What am I doing next? So negative 2 times 2x squared, I did that, and then plus negative 2 times negative 3x plus -2 times -4. Phew. Nasty. Right? But now we get to clean this up a little bit, right? And so we get 2x to the power of 3 minus 3x squared minus 4x squared plus 6x plus 8. I better check my pre-made answers here. Don't want to mess up a negative or something like that. That'd be silly. Okay. So now it's time to collect like terms, right? Whatever like terms we can find. So first I'm going to scan the crowd for an x to the power of 3. There's only the 1, so that's fine. I'll put 2x to the power of 3 down. And then now I'll move on to my x squared. So I've got negative 3x squared and then minus 4x squared. I'll just do this instead of writing it out again. So negative 3 minus 4 is negative 7, so minus 7x squared. And then I've got minus 4x and 6x that I can collect. And so I get negative 4 plus 6 puts me at plus 2x. And then the 8, there's no other values that I can collect it with. Okay. Any questions about that one? A little bit bigger, but same method. Yeah. Good. Okay, if I scroll up a little bit. Okay. What if I asked you to simplify 3y over 1 plus 0.06 times 175 over 365? If we have to simplify this, right, we have to keep in mind that we have to abide by BEDMAS, but also we're going to do the top and the bottom separately, right? So we'll simplify those separately until the very end, then we can combine them. Okay. And so the top, the numerator is just kind of, it is what it is. 3y, there's nothing we can do. To simplify this, but I'll just write a little note here. We deal with the numerator and denominator independently. Oops, what the? Until the final exam. No, simplification. Hey, less talking back there. Okay. So we're going to deal with the denominator now. And so we've got brackets, right? So we're going to have to deal with what's inside the brackets first. So then we go inside the brackets. There's no more brackets, so that's good. Now we've got multiplication and division. It actually doesn't matter which order we do it, but I don't know. We could rewrite this as multiplying fractions if we wanted, right? And then it's not so bad. So we get 1 plus, and then in brackets, if we rewrite this as 0.06 over 1 times 175 over 365, it's just an option, doesn't change anything, right? But now it's nice to be able to multiply fractions, right? Because we just multiply across. And so now we've got 3y over 1 plus 0.06 times, 0.06 times 175. I get 10.5 over 1 times 365. I can do in my head 365. I'm not bragging or anything, but I can do it in my head. So now we've got 10.5. So we've still got those brackets. They can actually disappear. They're not doing anything, right? They're not separating anything from a multiple, or they're not doing anything, right? And so we can kind of ignore them. And then we look at, okay, well, we have addition, but we also have division. So we have to deal with that division before we can get into adding it to 1. And so 10.5 divided by 365. I get 3y over 1 plus 0.02876712329. Now, of course, you don't have to write those all out, but I tend to get carried away and just write them all anyways. Plus 1. So now I have 3y. Hello. 3y over 1.02876712329. And I showed you how to store these big numbers in your calculator last day, right? So that's really handy. I'm on this different calculator, but I think it works the same way. Maybe not. Oh well, I'm screwed. No, that's okay. Oh, what? Keeps adding. Anyways, we can still simplify this, right? Because 3 over 1.02 whatever can still be condensed into just one number, right? And so what we can do is we can actually pull out the y, simplify that fraction, and then just have a coefficient and y left. So we can do 3 divided by 1.0287. And I get 2.916111.851 y. Okay. Any questions about that one? Okay. All good? Expanding, yeah. Yeah. Because you can just pull out the y to the side for a little bit, and condense it. Because what I'm doing is here, to get from here to here, I'm actually doing 3 over 1.028 times, I'm separating them and saying times y on the side. That's still legal, right? Because then when I can, but then that's how I can kind of put y to the side, simplify 3 over 1.028 to one number, and then multiply it by y again. Right? So we can do that. All right. Any other questions about that one? Oh. Let's do section 1.5, which I think is really fun. I don't know about you guys, but we're going to be solving systems of equations. So a system of equations looks like this. So a system of equations looks like maybe something like 4x plus 2y equals 8 and 2x minus y equals 7. Right? That's a system of equations. Right? Just a couple of equations. Two equations and two unknowns, right? X and Y. We don't know X and we don't know Y. In general, the number of unknowns that you have, that's how many, at least how many equations you need. So if you have 3 unknowns, you have to have at least 3 equations, right? We have 2 unknowns, so we need at least 2 equations to be able to solve for it properly. If you've got 15 unknowns, you need at least 15 equations, and it gets very big, right? We're only going to be dealing with 2 equations, 2 unknowns, right? And that's plenty. But I'll just make a note of it here. So to solve a system with 3 unknowns, we would need at least 3 equations. Put in brackets, independent equations. Doesn't really matter for our purposes, but just, I can't give you false information. Oh. Do you guys remember the equation of a line? The equation of a straight line typically, I think in high school, they use y equals mx plus b. Right? Something like that. Where m is the slope because it's attached to the x, and b is the intercept. Notice that this has an x and a y. And so really what this system of equations is, it's just 2 straight lines. Okay? For our purposes, they'll usually be supply and demand curves, right? And so to solve this system, we're actually finding the equilibrium point. I don't know, have you guys seen supply and demand curves quite yet? Maybe if you've taken microeconomics, it's all supply and demand curves, right? So we're going to look at the math behind it. But essentially, it looks something like this. You've got your X and your Y axes here, and you've got your line and another line. Whatever they are, whatever the equation is, right? We've got a positive slope and a negative slope. It doesn't really matter, but at this point here, I'll highlight it. At this point, there's an X and a Y, right? So at this point of X and this point of Y, that's your equilibrium point, right? And so this is the equilibrium point. The point of intersection, right, or the equilibrium, is also the solution to the system, right? That's where they cross, and that's where you'll find equilibrium, and that's what we're always looking for, right? And so the point of intersection is the point of equilibrium. Oops. It's the point of equilibrium which is the solution to the system. So when I ask you to solve a system of equations, this is what you're doing. You're finding the point of intersection. So we need to find the X and Y that satisfy both equations at the same time. That satisfy both equations at the same time. There's two ways that we can, there's probably more, but there's two very common ways of doing this. If you keep going a little bit into math, then you'll learn about matrices, and then you can just use matrices to do all this math, and it's really fun. But we won't use matrices. We're just going to use either by substitution, which is kind of my favorite, or you could also use by elimination. Okay. So I'm just going to write out what they all are, and I'll show you some examples. So there are two common methods. Two common methods for solving systems of equations. First one, by substitution. Okay. Which says solve for a variable. So pick one of the variables that you're going to solve for, right? And then plug that into the other equation, and then one of those variables disappears. Now you only have one variable that you can solve for, and then you can take that and plug it back to the one that you just were working with initially, right? So that's by substitution. Like I said, that's my go-to way, because that's how my brain works. But I'll show you elimination as well. So, but first let's write this down. So solve for a variable in either of the two equations then substitute the results into the other equation. Solve for the other variable. Solve for the other variable. And then use the solution to solve for the first variable. I'll get all this writing out of the way first. Or we could also use the second method, which is by elimination. And so the second method is by elimination. Okay. And it just helps if I show you the equation, but I know you're still writing, so give you a little time. So by elimination, it's just easier if I show you here, is where you say, okay, well, what I can do is I can multiply, as long as I multiply the entire equation, I can multiply it by some number, right? For example, if I multiply this entire equation, this top one, by 2, nothing's changing, right? I'm just scaling it up because I'm multiplying this side by 2 as well, right? So whatever I do to one side, I have to do to the other, but I'm allowed to do that, right? And so the idea is we take a multiple of either one of these and add or subtract it, whichever is more convenient, from the other one, okay? And we want to play our cards right. And so for me, looking at this as an example, and probably what I will end up doing, I would multiply this equation by 2, for example, because then I've got 4x minus 2y is 14, right? And now I can take this equation minus this equation, or sorry, plus this equation, because there's a minus there. That's why I liked it, because I get to add them. Then when I add these, I get 2y minus 2y, so now the y's disappear, right? And that was the whole goal of it. So either way, substitution where we're solving for y, let's say I'm putting it back in, we're getting rid of one of the variables temporarily, right? And so elimination is pretty fun, but you do have to kind of stay focused, because for me, I either add when I meant to be subtracting or things like that. And so you kind of have to stay on the ball. But we'll do an example, or maybe even 2. But by elimination, we take a multiple of one equation and add or subtract, right, whichever one works for you, and add or subtract it to the other equation, in order to eliminate one of the variables. In order to eliminate one of the variables. Now you'll be left with one variable that you can solve for. So now you will be left with one variable which you can solve for then use that solution to solve for the other variable. Okay. Let's see these in action. So again, I'll just use that one that we had before. Solve 4x plus 2y equals 8 and 2x minus y equals 7. I find it helpful to label each equation as equation 1, equation 2. Otherwise, you get them all mixed up and it's a mess, right? So I'll just put beside here equation 1 and equation 2. And usually, I kind of write little notes to myself about what I'm about to do, right? I'm going to solve for x in equation 1, for example, right? And then I do that, and then I kind of know where I'm at. And so we've got lots of options. Solve by elimination. Oh, sorry, that's not the first one. We'll do them in order. Sorry, I got carried away. By substitution. Right. So if you're solving this by substitution, and it doesn't matter which way you choose, right? As long as you know how to use one, you're fine. Okay, so figure out which one you like, stick to that one, forget about the other one, don't worry about it, right? As long as you know how to solve systems of equations, I'm happy. I don't care how. I'm not going to, on the test, I'm not going to say by elimination or by substitution. I'm just going to say solve this however you want. Okay? So we'll start by substitution. So remember, the idea is that we're going to solve for x or y in one of these equations and plug it into the other. Okay? And there's lots of options. I mean, there's 4 options. You can solve for x in equation 1. You can solve for y in equation 1, or x in equation 2, or y in equation 2. It doesn't matter. Just pick something that's going to be easy to deal with later, right? Then as you practice, you'll see what's going to be easy and what's going to be hard. Typically, dealing with fractions is not that fun, right? You have to add fractions, subtract fractions, yuck. Okay. So let's do something like, well, let's see, what do you guys think would be easiest to solve for? I think it's going to be easiest to solve for y in equation 1. only because I don't want to have to deal with that negative, but if you're fine dealing with that negative, then that's great. Okay, but I will solve for, well, which one do you want to solve for? Let's solve for y, but in which equation do you want to do? 1? You got it. Equation 1, coming right up. Solving for y in equation 1. So equation 1 is 4x plus 2y equals 8. Solving for y, right, we get 2y is 8 minus 4x. And I've got a page break here, so I'm just going to move it down here. Y is 8 minus 4x over 2. So y is 8 divided by 2 minus 4x divided by 2. All right. Careful how you distribute your fraction. Oh, whoops. So we get y is 4 minus 2x. Okay. This came from equation 1. Right? And so that means we have to plug it into equation 2, because if we plug it into equation 1, then we're just going to end up back where we started. Right? So it has to go into the other equation. Okay, so now substitute y equals 4 minus 2x into equation 2. Equation 2 looks like 2x minus y equals 7. We're going to substitute y equals 4 minus 2x into this. So we get 2x minus 4 minus 2x equals 7. We're going to expand this, right? Because the whole goal is to solve for x now. And so we're in a solve for x exercise. 2x minus 4 plus 2x equals 7. We want to collect like terms, and we want to move the 4 over to the right-hand side. And so we get 4x is 7 plus 4. So 4x is 11. So x is 11 divided by 4. Okay. 11 divided by 4. I always like to check in case it's a nice decimal to deal with, right? And in this case, it is 2.75, which I don't know about you guys, but I find much easier to deal with than fractions. If it was a nasty fraction, I'd probably encourage you to keep the fractions, but yuck. X is 2.75. Okay. So now we know what x is. Now we can plug that back into our equation for y to solve for y. Okay. So now we use x equals 2.75 to solve for y. Remember, we said y is 4 minus 2x. So 4 minus 2 times 2.75 is 4 minus 5.5. I get negative 1/2. For y. Okay. All right. So that means when x is 2.75 and when y is negative 1.5, that's where we're at equilibrium, right? So therefore, are you guys okay if I use the therefore dots? 3 dots in a triangle, therefore? Cool. Therefore, the solution to the system is at x equals 2.75 and y equals negative 1.5. Okay. Or in point form notation, right? So point, oh, now I'm drawing a blank what it's called. But anyways, the xy coordinates, right, is 2.75 comma negative 1.5. The xy coordinates. So it's a lot of work, right? But it's not hard, right? You just have to go through all the steps, right? But especially by substitution, then the steps are always the same, right? You solve for one, you plug it in, you solve for the other, you plug it in, and then you're done. Right? What's nice is we can check our answers, right? When we're solving system of equations, we know, scroll all the way to the top here, we know that x equals 2.75 and y equals negative 1.5 has to make both of these equations true, right? So we can plug in our values and just double check that we get the right answers, right? If we don't, we've done it wrong and we have to go back and look, right? So that's what's really nice is you have the option of checking your work. Okay, and so it is always a good idea to check your solution in the system. Right, we had equation 1 was 4x plus 2y equals 8, right? And so if we plug in 4 times 2.75 plus 2 times negative 1.5, the question is, does it equal 8? So I'll just put a little question mark up above until we've confirmed it. But 4 times 2.75 is 11 plus negative 3, which is 8. All right. We'll check the second equation too. 2x minus y, does it equal 7? When x is 2.75 minus negative, oh, what the? Negative 1.5. Does it equal 7? Get rid of this question mark. That one's still true. We get 5.5 plus 1.5, which does equal 7. So we're good. Okay. So that's nice that we can check our work. So that's by substitution, right? Let's have a look at the other way where we use elimination instead. Solve by elimination. Right, same equation because I'm not that creative. We've got 4x plus 2y equals 8. And what was it? 2x minus y equals 7. Still equation 1, still equation 2. Okay. Changing gears a little bit, see if you like this one better. Right. We said we're going to take a multiple of one of the equations and then add or subtract our two equations to try to eliminate one of the variables. Okay. I'd feel like I was cheating if I said I want to do the y's, right? So I'm going to ignore those, but that's probably the easiest thing. What could I do if I wanted to eliminate the x's? Easiest thing would be multiply this equation by 2, right? And then subtract the 2, right? 4x minus 4x is 0. Now x is gone. That would work. Yeah, so that's where we have to be careful, right? Because then it changes in here and it gets a little, right? Another option, these are all divisible by 2, right? So we could multiply by 1/2, which is the same as dividing everything by 2, right? We could do that as well. If you want, you could do 4 divided by 2, 2 divided by 2, 8 divided by 2. As long as you do it everywhere, it's safe. Okay. But let's, just so we have a look and see how careful we are, right? Because we said, okay, if we multiply this one by 2 and then subtract, right, then we have to be careful with these negatives in here, right? So let's do that one because it's the riskiest. We like living on the edge. So there's definitely easier kind of gentler ways to do it, but we'll do the hardest one, I think. Okay. So we will eliminate x by multiplying equation 2 by 2 and subtracting from equation 1. Okay. So because I'm going to be dealing with these two kind of together, I'll write them both out at the same time, right? And so I'll always have them together. So I've got 4x plus 2y equals 8. That one's staying the same. And then what I said my plan was to subtract, 2 times 2x minus y, oops, not end of bracket quite yet, equals 7. I wanted to subtract that from that top equation. Okay. We're not dividing, we're subtracting them. And so here, I'll get rid of this line because I think, is that the one you're asking about? And I'll get rid of this for now. How about that? We'll do step by step. So now we've got equation 1 here, equation 2. Okay, so equation 1 stays the same. We're just going to write it out. 4x plus 2y equals 8. And then we've got 4x minus 2y. That's not. Oh, never mind. It's safe. Say that again. Yeah, but we're going to subtract them. Right. So now, subtract 1 minus equation 2. Right? And so we've got 4x plus 2y equals 8 minus, so this is minus now. Now I'm stacking them as if I'm working with them algebraically. 4x minus 2y equals 14. Because I'm just going to deal with them like this. Okay. And so 4x minus 4x, that's 0. That was the whole goal, right? To get rid of one of these variables. Now we've got 2 minus 2y, or minus negative 2y, which is actually 2y plus 2y. So we've got plus 4y is, and then we have to do 8 minus 14, negative 6. From here, right, use 4y equals negative 6 to solve for y. So now we get y is negative 6 over 4, but that is just y is negative 1.5, which is the same as we found earlier, so that's a good thing. But you can see why this was, well, this was the hardest option that we chose to do, right, as an example. But also, I think substitution is easier. That's just me. But now, you can take this y and you can plug it into either of the two equations and then solve for x, right? We can use y equals negative 1.5 in either equation. In either equation to solve for x. Right. Just for simplicity, let's just use equation 1. Doesn't matter. And we have, let's use equation 1. Right. 4x plus 2y equals 8. Plugging in y equals negative 1.5, we get 4x plus 2 times negative 1.5 equals 8. So now we've got 4x minus 3 is 8. And then 8 plus 3 is 11. So we've got 4x is 11. And x is 11 over 4 again. So x is 2.75. That's a relief. We get the same answer either way. Right. So let's see if I have another. Yeah. So for these, just pick one way that you like and really practice it. Forget about the other way. Right. Whether it's substitution or elimination, just focus on one of these methods. Forget about the other one. Right? Yeah. How about, what if we have something like, example 28. What if we have to solve for, actually, I'm going to move this because I've got a page break here. May as well put it all on a new page. Solve 2x plus y equals 4 and x plus 1/2 y equals 2. Okay. Again, we're just going to label these equation 1, equation 2. That's great. Right. And well, actually, I'm curious. So Who likes the first method, the substitution method? I do. Everyone does. Oh, that's so fun. How about the elimination method? Rah, rah, rah. Great. I feel like some of you don't care. You'll do either. That's great. But I'm going to use the substitution method because I find it easier. Shh. Hey, 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 hey. Okay. So I'm going to use substitution. You can use whatever method you want. Okay. But I'm going to solve, well, what's easiest? I'm going to solve for y in equation 1. Okay. I just picked one that's on its own. It doesn't have a coefficient to deal with. I don't really like fractions, so I'm avoiding those. I'll have to deal with them at some point, but. And so equation 1, remember, is 2x plus y equals 4. And so solving for y, I get y is 4 minus 2x. That was quick. All right. So now I'm going to substitute y equals 4 minus 2x into equation 2. Can't put it back into 1 because I'll just get back to where I started. Has to go into the other equation. And so equation 2 says x plus 1/2 y is 2. So I'm going to plug in my y in here. So I get x plus 1/2, and then inside my brackets now, because 4 minus 2x has to take the place of y, right? So I have to put it inside brackets. 4 minus 2x equals 2. Okay. And so now we have, okay, I'm going to expand this, right? Bring the 1/2 inside. And so I get x plus 4 over 2 minus 2x over 2 equals 2. So I get x plus 2 minus x is 2. But wait a second. Right? Uh-oh. Okay. So we get x minus x, that disappears, and then we're just left with 2 equals 2. We can all agree that that's true, right? But what this is telling us is if you get to something like this, where you have a true statement, 2 equals 2, that's true, right? It means you have infinitely many solutions, because it doesn't matter what you plug in for x, right? No matter what value of x you use, you're always going to get 2 equals 2 in the end, right? Because they're going to use the same value of x, right? And it just stems from the first one being a multiple of the second one, right? And so they're basically on top of each other, and so you have infinitely many solutions. Okay, so since 2 equals 2 is a true statement that doesn't specify what x is, we have an infinite number of solutions. We have an infinite number of solutions. Number of solutions. Okay. In a similar type of scenario, right, if we end up with a statement that's false at the end, say something like 1 equals 2, that's false, right? It actually tells us that we have no solutions, right? And so similarly, or in a similar scenario, if you find a false statement, like 1 equals 2, for example, there are no solutions. So these are special cases where we either have infinitely many solutions or we have no solutions depending on what happened, right? If you have a true statement, you have infinitely many solutions. If you have a false statement, you have no solutions. Any questions about that? No? Okay. Well, like I said, well, we'll leave 1.6 for next day. You could use this time to work on assignment 1 if you want. Otherwise, we're done for today. See you guys on Tuesday.
Is it just something that you print? Put it online.
I will show you. Bye, Brett. I think it was it Brett? Yeah. Bye, Brett.